Welcome to Embedded. I am Alicia White alongside Christopher White. We're going to talk to David Kummer, an engineer whose career spans from Galileo missions to today.
Hi, Dave. Welcome to the show.
Thank you.
Could you tell us about yourself?
Well, how many hours is this again? No. So I actually span prior to Apollo. I got into electronics when I was 6 years old, believe it or not, and it wasn't serious at that point. My folks and I, my sister and I, family was down in Disney World in Florida, and I watched a DJ in a booth, and I thought, this is what I want to do. So I knew what I wanted to do from age 6. I actually started building. Yeah, I thought, all that equipment looks really cool. I thought maybe that would be fun. And the DJ part was appealing because, hey, here's this famous person. You had no idea what he was saying, but it looked cool. The thing, the catch for me was really the equipment behind and what was going on. So I started experimenting. These are probably way before your time, but the Radio Shack P boxes, do you ever remember those or heard of them?
I probably do, but it's probably lost to memory.
I didn't grow up with electronics, so.
Oh, well, way back when Radio Shack had these little boxes, and they're basically before Heathkit or maybe thereabouts. And so you put them together and you build them. And so I would do things like try to build radio transmitters in the garage. And I learned about rectifiers by touching a live rectifier, not realizing it was charged. So I learned that, I prefer 25 volts or less.
It's good to get that number established early in life, what your threshold is.
I actually, in high school, built a radio station, by myself. We had a second class radio engineer build the transmitter. It was called a carrier current. Later on, I got into public radio station in town called KANW in Albuquerque. It gave you experience. And from there, a lot of kids went to the big it's now called KKOB 770. I went to KOB, but not AM. If I'd gone to AM, maybe I'd be famous, probably not. But I went to FM, got into FM radio, it was Muzak back then. You change tapes, you do newscasts in the middle of the night, and you sleep in between the tapes, as a student in high school.
Why does that sound so romantic to me? That's a cool nostalgic. Now it probably wasn't that fun, was it?
Well, it wasn't WKRP in Cincinnati, but it was close. I would have preferred that Lonnie Anderson was there, but of course not. So anyway, from there, I went to KARS in Berlin, which is a 500-watt radio station. Berlin is like not 60, probably 40 miles from Albuquerque, and worked there on the weekends. Got myself into trouble once because I wanted to fix they call them carts. They're 8-track players that played commercials. And I was trying to figure out how to have a tight radio show. And I finally decided, I should take this cart apart and put a button in it so that I can cue it. And I did that, and I came back the next weekend and found out I was in big trouble because the engineer had been in, and he said he could have destroyed this. It was total horsepucky at that time, but they were pretty cool. But I went to New Mexico State, and that was where it really, really took off. So actually, to make a long story short, I got into space systems and stuff like that as a co-op, and later on got into the semiconductor industry. And later on, before I retired, I was working for a national lab. So I've been in electronics all my life. Okay,
and you have done silicon and hardware and software, right?
I have. I used to design chips.
What kind of chips did you design?
The 74HC family, which is the successor to the 74LS, high-speed CMOS. So those were a series of logic gates. It's what you built computers before microprocessors came about. And I did that at Texas Instruments.
Okay, so I have more questions about that. But I actually want to talk about your career as a whole. But before that, I want to do lightning round where we're going to ask you short questions. And we want short answers unless we don't, in which case, go on.
No problem.
What programming language did you learn first?
Actually, let's see. It was either assembly or basic. Let's say basic.
What programming language do you think new college grads should know now?
Not just one, many. Python, Go is a popular one. C and C++ are always good, but there are more that I haven't gotten into, but those are the ones I would recommend.
What is your ham call sign?
NM5DC, New Mexico 5, Dave Comer.
Nice.
Do you have a preferred way to learn new technical things? Reading videos, trying out without reading the docs?
Yes, all the above. Webcasts, reading, buying a book, working through it, you name it. I'll do anything to learn a new technology.
Favorite non-terrestrial object in the solar system?
Computer.
Okay. Do you have a favorite bug from your career?
Probably a software bug, but I don't know, grasshoppers. When I was a kid, we used to cut their heads off.
So to complete one project or start a dozen?
Oh, a dozen. I can't decide what I want to be when I grow up.
Do you have a tip everyone should know?
Yeah, if you ever have ice cream freeze, take your tongue and stick it to the roof of your mouth and hold it there, and that'll cure it.
All right. That seems really useful. We're going to have to go out for ice cream after this, Christopher.
All right.
Okay. You mentioned you were retired. What does retirement mean for you?
Taking care of my wife, believe it or not. It wasn't a decision that I thought long about. There's a long story behind that. I won't go into it other than to say she had a stroke, and here I am.
But you're still doing technical things.
Oh, yeah.
What kind of technical things?
Well, I do software-defined radios, something I'm into, embedded programming, playing with LoRa. I've got a whole series of gadgets sitting in front of me. So on a day, I just get up and decide what do I want to play with. And I'm working towards an eventual software-defined radio design.
How do you stay motivated to keep working in tech?
I have a paranoia that if I fall behind, it will become non-relevant. So I always keep my education up, and always I have 100 terabytes, of library that I'm always building and adding in case I need a reference library.
And so for the software-defined radio, are you working on an existing platform, or are you making your own hardware and software?
I'm playing with the Hack RF. I'm playing with the UHD, the National Instruments. I can't remember what EDIS. I'm playing with Elector Electronics has a software radio design that works with the Arduino, but pretty much I'm working with my own design.
And is it the software part that's fun, or the hardware part that you can do anything with radio part?
Oh, both. I like to say my left half, my brain is digital, and the right half, software actually, and the right half is hardware. So I work on both sides of the fence.
Where do you see that going, the SDR stuff? I paid a little bit of attention to it a few years ago, and then, like a lot of amateur radio people, fell out of amateur radio to do other things. I keep thinking of coming back, but where do you see that heading? Like replacing large amounts of hardware, or enabling new capabilities, or?
Pretty much enabling capabilities all the way from military down the way to personal. Xilinx has new chips coming out that I think are going to drive direct, you already have direct to baseband A to Ds. And with FPGAs, they're incorporating in. I think there's a lot of really cool avenues opening up. I think they're going to overtake microprocessors at some point, but I could be nuts.
In terms of?
Well, in terms of performance, in terms of scaling, today's chips, if you look at them, they would require a room full of circuit boards in the days when I started growing up. Now, with SOICs, you can get almost anything you want, and you can, if you don't have it and you have enough money, you can build it.
Gotcha.
So do you mean FPGAs replacing microcontrollers, or like the PSOC where it's a combination?
Think of it in terms of like a Zinc. I mentioned Xilinx. Altair is also a very good FPGA, and there are others. But the ARM9 being integrated into the Zinc several years ago was a hint to me to multiple cores and FPGAs. They go together. Way back when I started on the 8051, I used to design on that for Signetics. We used to have a group that sat around and came up with new ideas. And I kept thinking, why can't we put a RAM in to make it reconfigurable? And that's exactly what they have today in FPGAs with a better processor, though.
Were there things you've seen over the years that you've thought, okay, we should do this, and then a few years later, somebody finally does it?
Yeah, I've got a short story on that. Inside almost every microcontroller you find today, a PLL. And in those days, you're talking probably 1 megahertz to 10 megahertz. And I thought, well, why doesn't somebody put a PLL in these things, and you can essentially have any frequency you want? And I talked to some people about it. I just didn't have the knowledge to do PLLs. And had I been more proactive, I could have had the patent on that.
How do you figure out which new technologies you should really investigate as opposed to trying to not spend too much time on things that seem fly by night?
Oh, that's a great question, because I still haven't figured it out. I've got LoRa sitting here. I've got Arduino, which is, that's archaic by today. Bluetooth. I've got almost every technology, even analog, in front of me. And so I go between all of them. So that's probably one of my shortcomings, is I like working on everything. And nobody can do everything, and I try to do it. So if you saw my workbench, it's a sign of a sick person. It's really filthy.
It's the sign of a busy person.
An entrepreneur, I guess, would be a nice way to put it.
How do you manage to keep working with new and interesting technologies instead of being the in-house expert on legacy technology and products?
Pretty much reading and researching. To me, new technology isn't necessarily building the hardware. It's more reading about circuits and systems. Circuits and systems is a love of mine, and understanding the mathematics and how things work behind the scenes and trying to apply them. But I like sharing. I'm not really one of those people that's going to build the next Microsoft. I'm more of a in my days, it was you show people how to do things, you teach. So probably teaching would be a great avenue to do that.
And so in your career, have you been in a position where it looks like you're going to be stuck on legacy stuff forever? And how do you get out of that?
Oh, yeah. I used to work for Electrosonics, and they're an Albuquerque firm that builds wireless microphones and digital mixers. And I worked for them for a little while. I was building the software for end customers to program the mixers. And we're talking not audio mixers in the sense of concert mixers. We're talking about digital conference mixers that you see in big boardrooms. And I was boxed into writing the software, and I get bored really quick. So after about a year and a half, I wanted to get into the embedded and was told, no, I can't. We need you to stay on this for, foreseeable future. And I'm a renegade. So the way I get out of stuff like that is first of all, I have my resume is diverse enough that I can go pretty much anywhere and put it out. And they'll say, wow, we can use this or we can use that. So I'll just, do a job search. And some people are afraid to leave jobs. I'm not. I take it as a challenge. And so my career, you see a lot of my jobs, and some have asked about job hopping. And I always say, no, I've got to have the next challenge. in front of me. So,
what was the longest you stayed at a company?
13 years at Signetics, which was actually owned by Philips. And I went from Signetics to Philips, back to Signetics and Philips, because they had different opportunities. Semiconductors, you do that a lot, primarily because it's a very cyclical business.
How do you decide when to leave a company?
If you start getting cranky or...
Hey, well, wait a minute.
You can't quit. You're co-owner of this company.
Well, other companies. I start out cranky at other companies. So.
Well, you start to get, what's the word I'm looking for?
Bored?
Well.
Bored is a key one, but you start talking bad about the company, and you don't want to get there. That's a bad place to be. I actually got to that point at Intel, to the point where I was telling the manager, you really ought to lay off this department. We aren't doing anything useful. And I'm honest. I'll be straight up. And that's probably what did me in, because my next review was not good. And I said, that's okay. As it turned out, they gave me what's called a CAP, a corrective action program. And I thought, this is cool, because they say they'll buy you out. And I took a buyout. I got a $10,000 bonus for leaving the company and signed on with another company the very same day. So, you can make money off of leaving companies, but I don't recommend doing that. It's not something that's wise to do, because you don't want to get a bad reputation. But I've had a great reputation all my career, as far as I know. You'll always find people that don't agree with you. You'll find, as you get older, when you're working for younger bosses, you'll kind of wonder, do I really need to be here? But, there's always, never stop dreaming for the future. Don't get complacent.
How do you deal with the situation where you're thinking, I have T-shirts older than my coworkers or older than my boss?
Well, let's see. Do you guys know who Paul McCartney is?
Yes.
I met him once. So I actually no, I didn't. My ex-wife has this now. I had an old T-shirt from his Australian tour, which was a pride, and she used it as a nightshirt. But, I don't think anybody knows. Very few people today know. They kind of know Paul McCartney and the Beatles, but I've got T-shirts that go back to the 60s and 70s. So, you just don't try to go into too deep with, people that don't know who it is, because you can bore people.
But how do you interact with the youngins? Has that changed from beginning career to mid-career to late career?
Oh, yeah. As you get early in the career, you're competing with the young'uns because you're one of them. Mid-career, you're thinking, well, should I go in to be a manager? And for me, it was like, yeah, hell no. And then later on, I always stayed the technical ladder. And I realized that at some point, I was probably going to become lacking in newer technology. And boy, did I learn that later than sooner. But you listen to young kids, and I call kids, anybody under 30 to me is a kid. I'm actually going to be 63 this month. So you have to listen, because when I came out of college, I knew everything. When they come out of college, they know everything. But you know what? They do know a lot of good stuff. And to not listen to what they're telling you is foolish. So you listen to what they say, you guide. If you're in a position, well, actually I was recently, just before I retired, there were a couple of guys that I was supposed to be helping along on a project at my last position. And they had no idea of the terminology that I was talking about. It was kind of key for what they were doing. And I kind of moved them on to somebody else because they really didn't want to learn. They knew it all, and they really didn't want to understand the purpose of what they were doing. So I'll cut my losses if I have to. But on the other hand, those that want to learn, those that are anxious and say, give me something, here you go. Dig a hole as deep as you want, and have fun with it. And if you need help, let me know. But don't micromanage.
I think the diversity of thought that comes from young people who haven't seen everything is great, because they'll have new ideas. But oftentimes they'll have the same ideas that people had 30 years ago, and present them as new with a new name. Have you dealt with that in the past? And how do you politely say, we were doing that in 1985 or something?
Well, that's kind of funny you should ask, because there's a blog I was reading just last night. We'll see something. I wish I could remember it. And he had a comment on there. He was talking about KiCad, the schematic editor, the open source. And he said, I was looking for a squiggly resistor to put in there. I'm surprised they don't have it. And he said, somebody posted, oh man, those haven't been around for 30 years. And, I felt bad for him, because number one, it's not true. But, you don't just snap back at somebody and whatever. You kind of politely find a way to tell them, no, that's not true. The IEEE came out with a new set of not a new set, back in the 70s, came out with a schematic set that they tried to push. So I'm not really sure what this individual was saying, but I'm looking at a schematic now that has squiggly lines, and it's brand new. So, it's some people, I think you have to realize they're off the cuff and they're just trying to sound important. Other people may not know, but you shouldn't demean somebody for something they say. You should try to understand where they're coming from. Now, my wife will tell you, I wish you'd practice what you're preaching, but you have to have patience with people that are learning, because to them, everything's new and nobody's invented it. I mean, when I got out of college, I wanted to build the first digital stereo, and so did everybody else. And today, that's boring. So what younger kids are going to be inventing, I'm hoping will be something like three-dimensional conferencing. I'm surprised we haven't seen that. If you look at that Mars mission at the recent Embedded conference, what they did there is incredible. I mean, oh my gosh, I wish I were working on that. So, there's always something better coming along. The atomic bomb didn't exist, in the 40s. I mean, nobody wants an atomic bomb, but look at the effort that went into that. So anyway, I digress.
It sounds like your advice for interacting with the kids is both to listen to them and to hope that they're willing to let you teach them.
Combination. If they don't want to be taught to, I don't want to be seen as that old codger, that silver guy that is ready to retire. Don't listen to him. He's cranky and tell you all these stories about the good old days. Good war stories about what you did. It'll go only so far, but you can use that information not to tell them, oh, this is how we did it, but have you ever thought about doing it like this? You have to get into their head, and with anybody. And the term kids probably isn't appropriate, because these are young people that are out of college. They're not kids. They're not 8, 9-year-olds. But even younger kids that are 6 or 7 years old, they're learning, and you don't want to discourage them. And there's too many times in my career when I've been working on something and somebody will say, "Nah, it won't work. Tried it, been there, done it. Don't do it." And it's like, don't do that. Don't discourage people. Give them ideas, give them guidance, and let them create.
Let them figure out what voltage they.
What is your there used to be a commercial, I can't remember what it is, but what is your max voltage?
Exactly.
Some of these people are in megawatts. Just as an aside, I had a very good coworker that was into Tesla coils, and he was up in the 10 megavolt range in his garage. Almost killed somebody, but it's a funny story.
Okay, so your approach to the younger set has changed over your career. How about your approach to jerks? The people who aren't helpful, the people who are just jerks.
If you've ever read any of Dale Carnegie's stuff, and that stuff is pretty dated, but it holds true today, starting a fight with somebody. Well, I'll tell you, politics will get you in an argument. You should never discuss politics at work. That's one thing that will get you in trouble, could get you fired. It doesn't belong at work. I had a coworker that was really hot to talk politics. He was very passionate. And I could see where it was headed. It was almost headed to the finger pointing. I finally said, coworker, how about if I pick out a article that, I think you would like to read and you do the same and we'll discuss it. And that kind of settled it right there because he wasn't willing to do that. And so he realized, you kind of diplomatically get around stuff like that. But if you avoid confrontation, and I don't mean wimp out, you always have to have confrontation. Maybe somebody's got a design that's going to kill somebody. You have to stop it and say, no, we need to talk about this. But you don't point fingers. You don't, well, you shoulda, I shoulda, or, I told you so. You try to, Intel was really good about that internally, getting people to work together, and other companies have. Some other companies were confrontational, but everybody has feelings. And everybody has pride in what they do. And if you immediately come in and start accusing or saying you screwed up, or something, that's the best way to lose their interest. So that's what Dale Carnegie used to preach: is you don't you treat people like you'd like to be treated.
That's a nice idea. It's not always so easy.
Well, if you're this goes back to the Beatles, but if you ever listen to George Harrison's outlook on life, I could tell you a really funny story along those lines, but he treated people really nice. Here's a famous guy. And if you ever have a chance, watch the film Living in a Material World. I always liked him, but after I saw that movie, I was like, wow. He was my favorite Beatle after then because of the way he approached people's life. He was kind. He had a good outlook on life. So he was probably a good role model for me in my later life. This is actually before I met my wife now. And so, I kind of look at it like that: is you treat people nicely. I've been a total jerk to other people, and it keeps with you the rest of your life, and you don't want to have those memories as you get older.
It's true that the times that I have acted poorly, I regret more than I would like to. I mean, I wish I could go back and tell myself, no, this is not the right way.
You can't take it back either, but you don't want to dwell on it.
Has the social part, the human part of engineering, changed over your career?
Definitely. Social media, for one, although it's not, the hands-on electronics, but the internet came along. I think it was 1988 when we finally got fiber in Albuquerque, and nobody really understood it. But now it's like Twitter. You have so many social platforms, it's ridiculous. But the interaction, especially when I was in college, it's like, how come there's only males in engineering? Where are all the women? All the electrical engineers would say, yeah, the College of Business has plenty of females. Why don't we have females? And it's because it was a male-dominated area, and that's changed. If you look at NASA, and again, going back to that conference, and you look around the room and you see the type of people that are leading and are involved, it's totally different. It's really nice. It's all inclusive.
Has that been hard for you? I know it's been hard for a lot of people. Has it been hard for you? And if so, why, how, and how'd you get over it?
Oh, no, I adapted easily. The male back in I don't know how far back it goes, but at least until the 70s, when women started in engineering and being around, I think a lot of people had a bias in them. It wasn't obvious. I mean, with the EEOC laws and stuff like that, I think that facilitated it. But there were so many different variety of people from other countries, other sexes, things like that got into it, that you just accepted it. And you found that, hey, some of these people are pretty damn smart. You're one of the smartest persons I ever met was a gentleman from Hungary. And he was a PhD and taught me more than anything else in the world. That I can't tell you how in debt I am to him for some of the things that I learned, but you learn from all kinds of people. And when you when you bias people out because of who they are or what they might be, and you don't get to know them. I mean, how many times you met somebody and you hate them instantly, and then you find out later, wow, this is a really good person. What was I thinking? I mean, that's happened to me. So you learn to accept people and give them a chance, not prejudge. Now, I'm not always practicing what I preach, but that to me, that's the best way to approach it.
It's sometimes hard for me not to prejudge, but as I go on, I try not to act on that judgment.
It is hard. You have to catch yourself, I think, and realize what's happening, or you have to have prior experiences. Everybody's going to have a horrible experience in their life. I mean, you can't avoid it. What you can do is try to minimize those experiences by learning from them and drawing upon attention. One of the reasons I can come up with the answers so quick is I have self-talk all the time. And I started that when I started doing, what do they call them, behavioral interviews. And so I think I draw upon my experience all the time. And I've learned from all those experiences. I forget a lot, and then I remember, oh yeah, I forgot I did this or that. So you need the experience to have done poorly or badly at one time by somebody, and then you remember what it is, and you tell yourself, don't do that again. So I'm not sure that's a good answer, but it's the only one I can make up.
Well, sometimes if you can't be a good example, you can be a horrible warning, if only to yourself.
True. I guess I could draw upon the experience I had when my wife had the stroke a couple of years ago. I won't dive into that too much, but when you come home and you find a loved one almost dead, and you don't have any experience with that, what do? You learn about yourself. You learn the inner self. What can I do and what can't I do? And you go with it. So as it turned out, it worked out really well. But there are challenges in life you're not prepared for, that you just have to take them as they come and do the best you can.
That would be very tough. I mean, I think that would be tough for anybody. And I don't know that anybody could prepare for that sort of thing.
Oh, you can't. But, instead of, there's a little bit of insight when you go into a facility, a rehab or an ICU, where there are people like that. You'll see people that can't handle it, and they will abandon their loved one, spouse, whatever. Other people will sit there and say, well, it's not my job. That's why the medical people are there. And then you'll take the approach that I did, and that's show me how to do it. I have to take care of her when I get her home. How do I change her briefs? How do I do this? How do I do that? How do I teach her to walk again? Blah, blah, blah. I mean, just recently in the pandemic, if you want a good example, the rehabs were shutting down because you couldn't go into the outpatient with COVID. So I built a rehab in our house, and we weren't going to stop. We just kept going forward. So I guess from that, you learn, don't give up, keep going. Engineering's great, by the way, for that situation, because if you're a systems engineer, you can explain to your spouse how her brain is working and why she can't do this and that. So it's true. I gave her a whole lecture on feedback systems and why it was hard for her to eat. So she took it really well. She's a geek, kind of like I am, but I learned from my experience, take what I know and adapt it. Somebody told me early on in my career that just because you're an electrical engineer doesn't mean you can't be mechanical, chemical. You go to college to learn how to learn. And, you can do anything you want. You just don't say, I don't know this, so I'm not going to learn it.
That's important, that willingness to learn and that resistance to, I don't know it and it's too hard, I'm not going to bother. I feel like with engineering, we learn that resilience is a skill. The part where you say, oh, this is hard. And then you walk away for a little bit and then you're like, but I'm curious. So, I'll just push through.
Well, think about the mistakes that were made on the Mars. I'm keen on Mars because of Galileo, because I feel a special attachment to it, because that's the one thing you can say, hey, I did something, I went to another planet. But the folks that made the mistake between English and metric units and they lost the spacecraft, did they give up? Did they quit? Did they, say, I'll never do this again? Everybody makes a mistake. In my career, something more in my closer.
Their mistake, by the way, was naming their probe Beagle, because if they had ever met a beagle, they would know that it would not go wherever you wanted it to.
That's a good analogy. Not like a collie.
Right.
It's just funny though, because people make mistakes, and if you get punished, that's a big mistake. That was probably $100 million or more. But if you think back to the days of the initial Atlas rocket and the rocket engineers that were launching, and they would launch these things and they would blow up. Well, that was expected. And space exploration is really way different than most things, because the things they're doing, you have to spend a lot of money to figure this stuff out. But in everyday stuff, people make mistakes all the time. And, you have people that'll take it hard. You have people that'll handle it with anger. But you should never encourage. You should try to understand and be compassionate to some degree, depending on what they do. But you should never over criticize somebody. I've been responsible for losing probably $100,000 on one product I did at TI, because I had to redo a mask set, and nobody came to me and said, you screwed up. Although they did later at Signetics, but that's another story. Sometimes you just make a mistake, you fix it, but if you keep repeating it, then you need to. Somebody needs to work with you to show you what's going wrong. But anyway, I digress again. I'm good at digressing.
I wish I knew now. I wish I knew then what I know now about engineering, and the times that I was impatient when I was young. Because your example of the Beagle Mars probe that
wasn't the Beagle, by the way. That's a different failure.
Was that it? I thought that was the...
No, that was the British probe that landed but didn't unfurl its solar panels. Anyway, I just don't want you to impugn the wrong.
The meters versus miles per hour, or the kilometers versus miles. I see that. I have a simulator where we're working on AI stuff. And in my simulator, this half is in meters and that half is in miles per hour. So I didn't build the simulator. This is not my fault. It would all be in meters if it was up to me. But I can understand now how that happened, how the separate parts of a project just assumed that everybody thought the way they did, and how I need to be the sort of person that will check some of those assumptions and to go in and say, oh, that's really cool. Are you sure you're doing meters and you're doing miles per hour? Have you considered a conversion? Sort of oil over the water action. Mm-hmm. Do you get to do that very much, or have you gotten to do that very much, or is it a matter of just finding the problems?
It's a matter of the system. I suspect what happened to them was the system failed them. And that's one thing NASA has noted for the checklist, check, recheck, and dating all the way back to Apollo 11. The sheets, of course, when they had the problem, they had it invented as they were there, and Apollo 13 the same way. But that's what testability, that's what build to test, that's what a lot of the systems, and I'm sorry, I'm at a loss for a lot of acronyms right now, but that's why you have the balance and checks, where standards and procedures and check in, check out, and I'm kind of reaching the far gambit of what you do in software, but there ought to be something that says, you put the units in with what you're putting in, and something should flag you, like MathCAD. And this is very simplistic, but MathCAD will check units. Well, it seems to me that there should have been some unit checking and something that made sensibility. As an engineer, you should look at numbers and be able to judge for yourself whether this makes sense. Like, is it 100 million miles to the local TG&Y? They don't have those anymore. To the local Circle K or dime store or whatever. No, it's not 100 million miles. Maybe it's 1 mile. Somebody's off by 6 orders of magnitude. So I would suspect that it was more of a systemic problem than one engineer or a group of engineers making the mistake. So, that's why you have different evolving standards, and that standards are good. Some people consider them, they try to get around them because there are too many. But when you're dealing with that kind of money and safety, especially, there's not enough checking you can do, because you could be killing somebody if you're not careful.
So going back to the Galileo probe, and this sort of, you have to design with high consideration because the chance of failure is very expensive. What kind of design considerations did you have to consider?
Well, I'll tell you a story about that. I was working on it was called the memory control system, the D-spin section of the Galileo probe. I don't know, you guys sound like you're probably pretty savvy on space, but every satellite, the Voyager and everything else, had a spin and a D-spin section for stability. So the part I worked on was called the D-spin. And so it's not the real sexy part, the actual instrumentation, but it was an attitude control system to keep the probe from being like a gyroscope and spinning through space. And the individual I was working with, it was quite interesting. At those days, you could smoke in the laboratory. And when I first met this guy, he's standing over this chassis with a cigarette in his mouth and ashes pouring into a wire wrap fixture. It was a prototype. It wasn't something that was going out. But when I saw that, I was in horror and learned that what he did when the people came around in the lab to check things, he would take the cigarette ashes and put them in a drawer, out of sight. So I'm sorry, I kind of took your question and ran with that. But you learn things like that. Of course, I never smoked, but I would never, I had to make a decision right there and then. Do I go to the manager and say, this person was doing that? I could have ruined the guy's career. I probably should have said something, and that's something I regret in my career for not doing. But those are not things you want to do when you're building spacecraft, for sure. But there's other things you do learn about that that will apply, to your career later on. The part that he was working on, I'm not even sure they used it in Galileo. I ended up working on another part of Galileo. I can't even remember what it was used for. It's been so long, I'm starting to lose it. But things like the Galileo, one of the big controversies it had is the plutonium. It had to have a plutonium generator on it. And there was a big legal court case where people that were concerned about plutonium coming back into the atmosphere of Earth, rightly so, didn't believe, what the statistics weren't such that you could not worry about an accident like that happening. And that's why it's important to have balances and checks, because it's true. Somebody could make a mistake and you could have a very dangerous radioactive element that could kill a lot of people coming back into the atmosphere. But fortunately, what they decided to do is use Earth's gravity and other planets to swing it around. They still did launch it, but I think it was a smaller reactor, if I remember. But that's a critical thing that can affect, people's lives, even though you're sending it to another, planet. So it's important. And I forgot your question. I kind of went off on a tangent. I apologize.
No, that's, we've all seen the rockets blow up throughout all of our space history. They
Challenger.
blow up. Yeah. And so, of course, it would be a consideration if something has plutonium in it. But my question was, what kind of design considerations do you have working in unprotected space? Or that was going to be my question.
Well, definitely radiation. In the semiconductor industry, we used to joke around alpha particles. And I think in this embedded conference, I forgot the guy's name that was doing the talk, but he was talking about parts of memory, having to reboot. And one of the big things you have to worry about in memories is alpha particles, which are, I believe, they're helium ions, if I remember my physics enough. That will go in and disturb a cell real easily. So you can disturb memory if you don't protect it. And even though you're testing on Earth, that's a horrible way to start a sentence. But when you're testing memory circuits on Earth, you still have to consider that, because even though it's a remote probability that you're going to have a disturbance in testing, if you do have failures, it's something you have to consider, because we still have radiation entering the atmosphere, although, thank God it's not damaging enough to affect us every day. But when you send something like that into space, how do you protect it? How much shielding do you put? Can you put? Well, let me just digress again back a little bit, because this will explain it. I worked on the Centaur rocket at General Dynamics, and I learned an important lesson when one of the technicians was taking me through their factory. I went out to reach to touch the shell of one of the Centaur second stage rockets they were building. And he grabbed me and pulled me back really quick. And I said, "Why'd you do that?" And he said, "Well, think about what you're about to do." He said, "The shell on that rocket is thinner than a dime. You could puncture that rocket." So I could have been responsible for losing, $100 million for the company because I was stupid. But fortunately, I had somebody that knew better than I was. I was the younger and he was the older. And he taught me an important lesson that day I remember to this day. Well, today, when you're building a spacecraft that goes to another planet, memory certainly is important. The processor, how do you protect the electronics? How do you balance the weight to value? Redundancy will do one thing, but space is a pretty unforgiving environment. So I'm not an expert in that aspect of it, but I do think about stuff like that even on Earth.
I know I've put a few random bugs down to alpha particles. Who hasn't?
Well, I guess mine were more gamma. No, I'm kidding. If I could, I better stop there. I get myself into trouble.
You've gotten to touch some interesting silicon. You mentioned TI's 74HC series. You mentioned to me National Semiconductor's a 4-bit microcontroller, yep, and an 8051. Which of those was your favorite?
I'm thinking it was a match between the 4-bit and the 8051. They have different aspects. They both used what's called a PLA, programmable logic array, which is not an FPGA. It was the precursor. So they were hard-coded logic. And I learned how to make state machines and stuff like that in a 4-bit. I also learned the process. I learned how a machine like that works. But the 8051 was the same thing, but it was a little bit more important and used in a lot of different situations. So they're
Still
very
is.
same.
Yeah.
Oh, yeah. We're probably typing on one, the 8048, in some of these keyboards, which is a derivative. But they both have similar. They're both von Neumann machines. The arms that we're working on are totally different. And by the way, my boss, who I was working for at Signetics, first introduced me to the concept of reduced instruction set. And I thought it was really cool. The guy, David Patterson and Hennessy, who were pretty much, they're not the founders. I think it came before them, but they were the ones that drove it. We have a lot to be thankful for what they did, for the industry, the embedded.
Because of risk or? Because
of what it did, low power. The microcontrollers we have today, if we had 8051s today, we do in various forms, but it's so much more powerful in speed and power. At the conference, do you remember Miro Samek?
Oh yeah, we've had him on the show before.
Have you ever delved into his technology at all? Do you understand what he does?
The UML state machine focus?
Well, it's more important is state machines, but what he does with state machines, I don't think a lot of people do appreciate, but I don't think people realize how powerful it is. Miro is a genius. I can't discuss why I know what I do, but I've worked with some of his stuff and I've seen some of the things you can do. And I'm thinking in terms of low power. Systems, Silicon Labs, for example, will advertise microcontrollers that'll stay powered up for 10 years. I think with Miro's technology, they could extend it a lot further. And so I'm a big fan of his, if you can't tell. The guy is, when I saw his website and the state machines, I fell in love with the technology. I haven't written anything myself, at least not on my own time. So, yeah, I have to say I'm speaking out of the side of my mouth, but I do know that his stuff is very powerful. And I would encourage anybody that is doing low power to look at it because you learn quite a bit from it. But anyway, there I go off on a tangent again.
That's why we're here. It's all tangents all the time.
It is.
No hypotenuses at all.
Nope. And that reminds me, one of my favorite sayings is the world is complex. Part of it's real. The other part's imaginary, right?
That's good. I like that.
It's true. I worked with this guy that had the best analogies I've ever heard. Things like paint it white, shine it bright, hope the hell it works right. Now that's when you're getting tired of being at a company because you see things done wrong, incorrectly a lot of times. Another one of his was ignorance should be painful. And that's a truism.
It should be. It should be a lot more painful than it is.
Yeah. You learn a lot, a lot of, like I say, war stories. But I think when you look back, summarize my career, I guess. I've had a great career. I've had more opportunity in my life. Sometimes I worked at a national lab as part of my career, and I really enjoyed that. But I felt that I've worked at more in the jobs that I have than most of the people that I was surrounded, because a lot of people will go to a company and they'll be with them forever. And that used to be the paradigm in the 40s and 50s, and it's still good. You want to be loyal to any company you're working for because they're paying you. They don't have a requirement. Well, you have to be paid, but for what you do, but they don't owe you anything. Today, though, they can lay you off in a day or a week, and so you have to be cognizant of, are you of value to a company? Are you producing what you say you are? Are you giving the stockholders what they need? But as a consequence of that, I always learn, don't be afraid to, move on to new stuff. It's never the end of the world. Keep striving for that next career is kind of the way I look at it.
Do you think that has changed some? When I started at HP 25 years ago or more, it was supposed to be a company you retired at. And this was HP before it was Compaq, before it split with Agilent, when HP had a DNA lab and when HP Labs was doing amazing, weird things. And they sent me to conferences. My manager always had things that I was supposed to be learning. And I talked to general managers occasionally, as an exciting thing. But now it doesn't seem like people get as many opportunities at companies anymore.
It can be because you don't create those opportunities. And I'm not saying in your case, but sometimes the people that make the difference between those that move on and make a huge difference are people that don't say, well, I'm just going to do this. And, I hate this adage, but the old battery stamp, somebody working in a factory for their entire life. You have to be always thinking about the next possibility. HP, it started in the garage, for goodness sakes, and look at where it got. They actually had a huge disk drive design. I worked with them, and I got to see that part of it. But HP grew beyond. I think I have to say they grew beyond too big. They had a policy of, when they got to 2,000 employees at one campus, they split the campus, even in the same town or city. And the problem was, I think, infighting and politics at the end between the stockholders and Dave Hewlett and Packard. I think, I don't know what part Cauliflower had in it. I certainly wouldn't judge it because that was more political than anything. But there were some nasty things going on. And I think infighting in the company had a lot to do with it. HP was a great, great company. Their calculators, their printers. I worked on numerous HP computers early on, and I was really heartbroken that they went the way they did and became Compaq, because Compaq doesn't exist. HP still survives, but they're making printers, and I forget what else they're doing now.
Computers.
Do they still make? Yeah,
they make computers.
Yeah, but you don't hear about that. You hear about Dell's and Apple now. So I don't know. And I mean, most of the companies I work for, Signetics doesn't exist. Philips doesn't exist, at least not in semiconductors. It's now called NXP. What was the first one? TI exists, but I think TI is surviving. Thank God. They're a great company, but National Semiconductor, they don't exist anymore. They're Analog Devices. Is that right? I forget who acquired them. I think it was Analog Devices. No, TI did. And then
I know.
It's so confusing sometimes. And then you look at these data sheets and they say, they still say Atmel for all of the Atmel parts. Things. And I'm just like, I wish it was Atmel and not Microchip.
I've always been a fan of Atmel. ARM is by far, in my opinion, is the bigger of the two between MIPS and...
Certainly now, yes.
Oh, yeah.
ARM is definitely winning.
Well, it used to be every router had MIPS in it, and then here comes ARM.
Yeah, worked on a lot of MIPS at Cisco.
I studied ARM so much, I made a mind map out of them all the way from the beginning. I have this mind map of the history of ARM, and it's amazing. I did this with atomic physics, by the way, of all the history of all the scientists and stuff. A mind map will really help you. It's a really good way to sort things out. But I still thought the DSPIC was cool. It was pretty much like the Analog Devices 2100 family, I thought. So anyway.
Is that the Shark family?
They did the Shark, but it wasn't that. The 21000, I believe, was the Shark. The 2100, the 2101, 2105, I think. I started playing with those for a while, but those were the architecture that was all pretty much. By the way, Intel, I think, pretty much did the first DSP. I don't think a lot of people know about. I forgot what it was called, the 2700. I sent an email internally to Intel to ask the guy that designed it was still there. And I sent him an email asking him about it. I was hoping to strike up a conversation, but he wasn't too friendly. That was sad. But, because there's a lot of good history in it, why they did what they did. So.
Okay, so before we go, you've mentioned conferences, and I know that the recent embedded online conference you must have paid for yourself, but you've mentioned other ones. Do you usually pay out of your own pocket, or do your companies send you?
A combination of books and conferences are the same. A lot of times your boss will not pay for something, and I just say, you know what, I'm going to pay for it out of my pocket. I've been fortunate. I've been able to go to the MSDN conferences, and the companies have paid for it. But there's a lot of other conferences, online, offline videos, and DVDs. If I need something, I'll pay for it. I'll find a way. It's too important to learn something. So, you shouldn't let your boss tell you what you can and can't know.
Dave, do you have any thoughts you'd like to leave us with?
Be nice to people. That's true. Treat people the way you want to be treated, and they'll respond kindly.
Our guest has been Dave Kummer, recently retired, but still learning.
Thanks, Dave.
You bet. Great talking to you.
Thank you to Christopher for producing and co-hosting. Thank you to our Patreon listener Slack group for questions, all of which I didn't accredit properly. So thank you. Sorry. And thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. And now a quote to leave you with from Norman Rockwell, of all people. The secret to so many artists living so long is that every painting is a new adventure. So you see, they're always looking ahead to something new and exciting. The secret is not to look back.